All right, so we're going to talk about equations of parallel and perpendicular lines today. So go ahead and take out your notes. I do not have a packet for you, but take out your spiral notebook, label it 4.3 notes, and write down this core concept, please. So, parallel lines and slopes. Parallel lines are lines that never intersect. All vertical lines are considered parallel. All horizontal lines are also considered parallel. Any other line that's not vertical or horizontal are parallel if and only if they have the same slope. Lines that have the same slope are parallel. So let's see what this looks like in practice. Also, if the video is going too fast at any point, just pause it so that you can finish copying down your notes into your spiral notebook. All right, our first example gives us this picture of the graph, and we want to determine if any of these lines are parallel. By glancing at it, they kind of look like they're parallel, but we don't really know. So let's find the slopes and see if any of the slopes are the same. So line A is the blue line. The slope of that is, well, it's on a graph, so I can count it. 1, so the rise is -1, I'm going down 1. 1, 2, 3, 4, 5 over, so the slope is -1/5. B is my red line. For my slope, I'm going down 1, so that's a rise of -1 over 1, 2, 3, 4. So my slope is -1/4. And C, oh, my pencil broke. C is my green line. And for C, my slope goes down 1. So a rise of -1 over 1, 2, 3, 4, 5. Oh, it keeps breaking. So my slope for C is -1/5. Parallel lines always have the same slope. So are there any two lines here that have the same slope? A and C have the same slope. So lines A and C are parallel. All right, moving on. For my next example, I want to write an equation of a line that passes through this point and is parallel to this line. Okay, so we know that in order to write a line, we need to have y equals mx plus b. We need the slope. We need the y-intercept. Well, it kind of told us what the slope is. If it's parallel to this line, parallel lines have the same slope. So my slope will be 2. Now I just need to find my y-intercept. For the y-intercept, what we're going to have to do is we have part of our equation already. We know the slope. We know our equation is y is equal to 2x plus b. The question is, what is the y-intercept? It is not 3. This is the y-intercept for this line. We are not just going to plug in 3 here. We actually have to figure it out. And the way that we're going to do that is we're going to use this point. X, comma, y. X, comma, y. We're going to substitute this point in and solve for B so we can find out what our new y-intercept is. So negative 4 is equal to 2 times 5 plus B. That will be 10 plus B. And B is going to be negative 14. Now we have the correct y-intercept, and we can put all of our pieces together. Y is equal to 2x minus 14, and that will be the equation for this line. So I want to reiterate, I want to repeat one more time. We are not using the y-intercept from the first equation. We have to find a new y-intercept because we're talking about a new line. So you take a moment and do these two. Go ahead and pause the video and see if you can figure out if line A and line B are parallel, and see if you can find an equation for this line. So pause the video and do it. When you are done, press play and see if your answer matches mine. All right, so for A, we don't have a graph this time, so we're going to have to use our slope formula. I'm going to make this point 1 and this point 2. We're going to y minus y over x minus x, and that's going to give me negative 4 over 1. So my slope for A is negative 4. For line B, I'll make this point 1 and this point 2, and my slope will be y minus y over x minus x, and that's going to be negative 5 over negative 2, which will be 5/2. This is not the same slope as this, so no, they are not parallel because they don't have the same slope. For number 2, we want to write a line that goes through this point and is parallel to this line. So we have to write an equation, y equals mx plus b. We already know the slope, because if it's parallel to this, it has the same slope. So my equation so far is y equals 1/4 x plus b. Now we need to find b. That's where this point comes in, x comma y. Let's substitute it into this line. 2 is equal to 1/4 times negative 4 plus b. This turns to negative 1. And b will be 3. Put it all together. Y is equal to 1/4 x plus 3. So there's our equation for our new line. Okay, go ahead and write this down. Perpendicular lines. Perpendicular lines intersect at right angles. But you can never tell just by looking at the picture if the angle is a right angle or not. You are going to have to look at the slopes. Perpendicular line slopes are negative reciprocals. So it's the opposite sign and flip, such as -2 and 1/2. Those are opposite reciprocals. And if you have vertical and horizontal lines, any line that is vertical is automatically perpendicular to any line that is horizontal. So let's apply this. For example 3, let's decide if any of these are parallel or perpendicular. In order to determine if the lines are parallel or perpendicular, we have to figure out what their slopes are. Remember, lines with the same slope are parallel. Lines with opposite reciprocal slopes are perpendicular. Line A is already in slope-intercept format, so we know the slope is 4. Let's do line B. We first have to put it into slope-intercept form, so I'm going to subtract x from each side. Then I'm going to divide both sides by 4. When I divide this side by 4, everything gets divided by 4. So negative x over 4 becomes negative 1. Oops. Don't know why I wrote 2 ones. This becomes negative 1/4 x plus 3/4. So our slope here is negative 1/4. I also have to put this into slope-intercept form. So I'll start by adding 2x to each side. And then I'm going to have to divide by negative 8 on each side. When I divide this side by negative 8, I divide everything by negative 8. So that'll be negative 2/8x plus 16 divided by negative 8 is negative 2. Simplify is negative 1/4 x minus 2. So my slope is negative 1/4. Which of these lines are parallel? Well, line B and C are parallel because they have the same slope. Line A is perpendicular to both lines B and C because 4 is the opposite reciprocal of negative 1/4, right? If I take negative 1/4 and I do the opposite, so that makes it positive 1/4, and then I flip it, I get 4. So negative 1/4 is the opposite reciprocal of 4, meaning that A is perpendicular to B and C. And then B and C are the same, so they're parallel. All right, for example 4, we've done this with parallel lines already. We want a new equation that goes through this point and is perpendicular to this line. This slope is 1/2. My new slope is going to be the opposite, so negative 1/2, and the flip. So it'll be negative 2. My new slope is negative 2. So far, my new equation is y equals negative 2x plus b. Once again, we have to figure out what b is. That's where this point comes in, x comma y. Let's plug it in. 1 is equal to negative 2 times negative 3 plus b. That's going to be 6. And b will be negative 5. So my new equation is y equals negative 2x minus 5. Remember, I'm not using this y-intercept. That's for that line. I have a new line. I have to substitute to find my y-intercept. So, you go ahead and pause the video and you do this one. So if we want a slope that's perpendicular to this line's slope is negative 3. We want to take the opposite, so we'll make it 3. And then we want to flip it, so we'll make it 1/3. So our new slope is 1/3. Our new equation so far is y equals 1/3 x plus b. We have to find b. That's where the point comes in. Let's substitute. 5 is equal to 1/3 times negative 3 plus b. That'll be negative 1 plus b, and b will be 6. Put it all together. Y is equal to 1/3 x plus 6. All right, for our last example, we have a picture of a helicopter search and rescue. The green line here is the shore. The shortest flight is perpendicular to the shore. We want to write an equation for that. So we want to write an equation for this line that is perpendicular to this line. So the easiest thing to do, well, the good news is this is a graph. So you can count for the slope. To count on a graph for a slope, just look for points that the graph actually touches. Looks like there's a point here, here, here. All right, so we got 3 points there. We can probably figure out the slope from that. From this point to this point, it's up 1, 2, 3 over 1, 2. Up 1, 2, 3 over 1, 2. So I can say that my slope is 3/2. Let's just double check that with the green line and make sure that they're opposite reciprocals. So here's a point on the green line, here's a point on the green line, here's a point on the green line, and the slope here will be 1, 2, 1, 2, 3. So down 2 over 3. 1, 2, 1, 2, 3. Yep. So my slope for this green line is negative 2 over 3. Are these opposite? Yep. Positive, negative. Are they reciprocals? Are they the flips? Yep. 2/3 and 3/2. So we have my slope. That is the correct slope. My equation so far then is 3/2 x plus b. We got to find that b. What do you know? They gave us a point for the helicopter, 14, 4. Let's use it, plug it in, and solve for b. 4 is equal to 3/2 times 14 plus b. That's going to be 21 plus b. And if I subtract 21 from each side, b will be negative 17. So my equation is y is equal to 3/2 x minus 17, and that will be representative of the flight path of the helicopter going to the shore. All right, that's it.